Welcome to TechBrain YouTube channel, where we make coding fun, simple, and efficient. Today, we are tackling an important topic: how to protect your APIs from abuse using Fast API and Redis. If you are building APIs, this is a must watch. By the end of this video, you will know how to implement a rate limiter to prevent abuse and control traffic. Let me quickly explain what we are going to do. Imagine your API is like a toll gate. You want to let cars or requests pass, but only a limited number of a given time, say 10 car per minute. Anything above that gets blocked. That is rate limiting, and we will use Redis as our toll gate gatekeeper. Here are what we will cover in today's video. First, we will understand the importance of rate limiting and its role in API security. Next, I will walk you through implementing a rate limiter with Fast API middleware. We will also explore why Redis is the perfect backend for managing real-time request limits. We will look at techniques for gracefully handling abusive requests. Now that we've set our learning goal, let us talk about the very thing we are protecting our APIs from: DDoS attacks. What exactly is a distributed denial of service DDoS attack? Picture a highway jammed with cars. A DDoS attack floods your API with so many requests that legitimate users can't get through. This causes slow response times, downtime, or even a complete shutdown of your API. API are often public facing and attract a lot of traffic, making them prime targets for these attacks. To defend against this, we use rate limiting. Let us explain what rate limiting is. Rate limiting is like a bouncer at the entrance of your API. It controls how many requests a client can make within a specific time frame. Its purpose is to prevent server overload and block abusive behavior. There are several types of rate limiting, which includes fixed window, sliding window, token bucket. Fixed window limits requests within fixed time intervals, while sliding window is a more dynamic approach to limiting requests. And also token bucket, which allows bursts of requests followed by a controlled rate. Now let us talk about why rate limiting is essential and how it protects your API. Rate limiting does three key things. Number one, it protects API resources. It prevents resource exhaustion from bots or malicious users. Number two, it improves user experience by enforcing fair usage. It ensures no single user hogs the server. The third point, it enhances security, blocks malicious actors, and safeguards your server from potential threats. Let me explain the sequence depicted in this diagram, which outlines how a rate limiter operates within the client-server interaction process, particularly when working with APIs. Let us break this down step by step. On the left, we have the client. This could be a user, an application, or any service sending multiple requests to an API. Think of the client as the one making demands, whether it is fetching data, submitting information, or performing some operation on the API. Moving to the center, this funnel shaped icon represents the rate limiter. Now, the rate limiter acts as a gatekeeper. It ensures that the number of requests sent by the client doesn't overwhelm the API. Essentially, it enforces limits such as only 100 requests per minute and blocks excess requests beyond that limit. Why is this important? Without a rate limiter, the API could get flooded with requests, leading to slower response times, crashing, or even service outage. On the far right, we have the API. After passing through the rate limiter, valid requests are forwarded to the API. The API then processes these requests and provides the appropriate responses back to the client. So, in summary, this flow helps protect the API by ensuring it only handles a manageable number of requests at a time. Now, let me explain how to implement real-time rate limiting using Redis. This approach is fast, efficient, and perfect for controlling API usage. Let us break down the diagram step by step to understand how it works. Here is how it starts. The client sends an API request to the server. The server then needs to decide if the request should be processed or denied based on the rate limit. Next, the API server interacts with Redis using the increment command, which increments the request count for the client making the request. If this is a first request, Redis creates the key for this client and starts counting. Redis returns the updated count to the API server. Now, the server checks if the request count exceeds the preconfigured limit. If the count exceeds the limit, the server immediately responds with a 429 too many requests error, letting the client know they have been rate limited. But if the count is within the limit, the server proceeds to process the request. To ensure limits reset after a specific time frame, the server uses Redis expire command to set an expiration time on the request count key. This step is only executed if it is a new key. Redis confirms that the expiration time is set, ensuring the count will reset after the specified period. Finally, if the request count is within the limit, the server processes the API request and responds with a 200 OK along with the appropriate response data. This ensures the client gets the information they need without overloading the system. So why do we use Redis for this? Number one, high performance and low latency. Redis can handle thousands of operations per second, making it ideal for rate limiting. Number two, built-in expiry feature. The expire command automatically resets limits after a defined period, simplifying the implementation. In this implementation, we mainly use two Redis commands, increment and expire. We use the increment to increment the request count, while the expire command to set the expiration time on the key. These two commands work together to enforce rate limits efficiently, and that is how you can implement real-time rate limiting using Redis. This method is simple, scalable, and keeps your system safe from abuse. Now let's start coding. Before we get started, the first thing is you need to set up the project. Make sure you have Python installed and then install Fast API and Redis. So before we begin, let us create a directory called rate limit. So let's seed into the rate limit directory. Let us create a virtual environment and activate a virtual environment. Here's how to do that. We've successfully created a virtual environment. Now let us activate our virtual environment. Now we've successfully activated our virtual environment. Let us open our Visual Studio Code. Now in our Visual Studio Code, let us create a main.py folder. In our Visual Studio Code, let us create a main.py file. Now let us install all the required libraries. You can see that we successfully installed all the required libraries. We installed Fast API and Redis. Fast API is for building the API, while Redis is our database for tracking requests. So now let's go back to our Visual Studio Code. Here's the plan. We will create a Fast API app with two endpoints. One will be protected by rate limiting and the other will be an open endpoint to check if everything is working fine. Additionally, we will use Redis to track how many requests each user is making and implement logic to block them when they exceed the limit. Now let's start coding. First, import the required libraries and connect to Redis. This connects our Fast API app to Redis running on localhost. If you are using Docker or a remote Redis server, update the host and port accordingly. Now let us create the rate limiter logic. This function will track requests from each client and enforce the limit. This function does three things. It checks if the client has a Redis key. Then, if the key doesn't exist, it creates one with a count of 1 and sets an expiration time of 60 seconds. If they can't exceed the limit, it denies the request with a 429 status. Now, let us create the protected endpoint. This is where we will call the rate limiter function to enforce limits. Here, we use the client's IP address as the unique identifier. If the client exceeds the limit, they will get a 429 error. Let us also add a simple open endpoint for testing and middleware to return headers with rate limiting details. The middleware adds headers like X rate limit remaining and X rate limit reset to give clients useful info about their usage. Let's test it. Start the app with the following command. You can see our app is running successfully. Now copy this, then paste it on your browser. Now let us test this endpoint. You can see the message in the response body which says this is a protected API endpoint with a status code of 200. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see it said rate limit exceeded. Try again in 54 seconds, which means our application is working successfully. So, and that is it. You've now built a powerful rate limiter to protect your API from abuse. You can see that when we send requests to API protected route, after 10 requests, you can see a 429 error which says too many requests, rate limited exceed. Try again in 54 seconds. And that is it. You have now built a powerful rate limiter to protect your API from abuse. This method is efficient, scalable, and ensures your API stays healthy under heavy traffic. To wrap up, rate limiting is a must-have for securing your APIs and ensuring fairness for your users. Fast API Redis make it easy to implement a powerful and efficient rate limiter. If you found this helpful, be sure to like this video, subscribe to the channel, and share it with your developer friends. Drop a comment below if you have any questions or suggestions for future topics. Thanks for watching, and I will see you in the next video.